Welcome to the talk on SFrame. My name is Indu. The title of the talk is a bit of a misnomer the more I've been thinking about what to talk about and so on. So we'll talk everything about SFrame, what have we done since we last met at Cauldron last year. And but towards the end, I want to reserve a good like 20 minutes or so because there are some things I want to discuss. And in that time, if you guys have something to bring up, let's have it towards the end of the talk. So I just said something like BOF. So this talk will be more interactive. Most of you, I guess, know about the stack trace format, SFrame stack trace format. Just to summarize, it's basically the minimal necessary information you need for stack tracing, right? It gives you explicit stack offsets to know when you're stack tracing to figure out what is the CFA, FP, and RA, right? So the stack offsets are encoded directly in the format, which is very different style of encoding information than what EHFrame does. Will not go into too many details, but the first version that we released was in 240. This is early 2023. And then fast forward to now, the last release that we did was SFrame version 2, errata 1. This was in BNutils 245. We do plan to release a SFrame version 3 in BNutils 246. I have some list of features that I want to target, and we'll talk about all of those. And I'm not sure if you see, oh, you do see the color. Yeah, so whenever it's green, basically I'm going to talk in detail about those aspects. Since the beginning, SFrame has had support for two architectures, two ABIs, x86-64 and AArch64, and in 245, as Jens was talking in his talk, just the previous one, we added support for S390X in SFrame version 2, errata 1. This terminology, I keep coming to it, so it's better to just settle this for now. So SFrame information is basically laid out in a section, in one section, right? The first few bytes are the SFrame header, then is there an index of fixed length entries called FDEs. FDEs, think of FDEs as just the minimal basic metadata information. So given a function, what's the start PC, what is the size of that function, and other information, which is very SFrame specific, like is this a PLT or is this a regular code block? And finally, this whole blob of data is the FREs, which basically is the meat of the stack trace information, like the stack offsets and so on. So for now, I think just FDE and FREs need to be remembered, as a keyword. I will not talk more about SFrame format. I think there are links for most of you guys know already, I guess. And if there is further interest, you can always start with some of these links. There should be enough information to start. So since we met last year, there have been progress in each of these four components. Toolchain support has been evolving. We have been adding more feature requests, bug fixes. Gentoo and Ubuntu have been very helpful in doing some distro-wide builds with SFrame support to see how things are, and some bugs were filed. We fixed some of those. There are two interesting bits around the stacks tracers using SFrame. So there is two flavors in the user space stack tracing side. One is glibc and the kernel itself. And on the kernel space stack tracing too, there is a use case which I will talk about. Evolving SFrame, again, I'll talk more about it, but overall there's a good amount of involvement from across communities, which is good to see. It's converging to a point where we want to see fast stack traces in the GNU Linux ecosystem. LLVM support is coming along. Yeah, their pull requests keep coming every now and then, so it's evolving. That's good to see. So I will spend the next few minutes just talking about how the toolchain support has evolved and what has been done. Just the key highlights, not to go in details. S390 support was added in 245. Jens talked about it, so I won't talk in detail about it. The two things which are worth mentioning is the relocatable links were fixed, and a new configure time flag was added, the enable default SFrame. So relocatable links was, again, if some of you were impacted by this, this was basically noticed when you were building kernel modules. The linker was doing something too smart, like it was it was encoding these data items as in the offset is from the section start, whereas the linker should be doing it right by encoding that data as the offset from the field itself to the text. But long thing short, yeah, it was basically mismatch between how the ET-rel objects stand as generated by the assembler versus LD-R. This has been fixed, and to fix that properly, we had to do a errata release. SFrame does not track minor versions, so we added a new flag, which basically now indicates that this particular field, which is indicating the start PC of a function, this particular field now encodes the distance from the field itself. The other change that we did do was we realized over time that so far SFrame sections had been carrying the section type of SHT proc bits. SHT proc bits is a marker in ELF that tells you, that basically indicates that these sections are concatenable, but then it's sort of it's a misuse of these section types. So we did add SHT GNU SFrame to properly indicate that this is a new section type. So an unaware linker in theory can still concatenate unrecognized section type, but at least tools can now see that this is an SFrame section without having you to check by section name. You can check a section type, and tools can then know that this is a SHT GNU SFrame, and they can do the right thing. So this was also added in BenUtils 245. And again, since no user space has been built with SFrame, so we took the opportunity to at least correct one piece of misuse around ELF specification and how SFrame sits as an ELF citizen. Next, yeah, this was an option added by Sam. Basically, there is an option called enable default SFrame. This allows you to build an assembler which can emit an SFrame section for whatever it assembles on the targets that SFrame is supported, right? So this helps you easily build a whole lot of user space with SFrame enabled. As a side effect of this flag, warnings and errors were silenced, and I know Matthias has some opinions about that, but we can also, one of the suggestions was to basically move this to the compiler, right? So the compiler is a better entity to see whether SFrame is supported for an architecture or not. It does make sense, so maybe we revisit some of this and see where is the common ground. But overall, yeah, it's been very helpful in just testing out what is, how robust is the toolchain offering with respect to SFrame usage for the user space binaries. There are open bugs, yes, the GC sections one being one of them. It's been outstanding. Mostly I do have a solution for it, but I think it's just being trickled down to the bottom of the to-do list. But there are ways to, there is a way to solve it, and I should post the patch soon. There are other minor unfixed versions, but they are all, they should be done by 246 release. Okay, user space stack tracer. So since we last talked at Cauldron, there was an ask to have SFrame support in the backtrace function in glibc. So Claudio did all the work, thank you. And this is now released in glibc 242. We did end up tagging this as an experimental release because it was too... It's a question. No, it's okay.
I think the backtracer is disabled, but the SFrame lookup support is included even if you don't enable the...
I see.
The experimental mode. So some parts that make sense are unconditionally active. So we're doing something slightly better. The backtracer doesn't make sense if you build glibc with the backtracing support because you get stuck immediately on the glibc frame which doesn't have SFrame. So. Okay,
so the enable SFrame only controls whether glibc is built with SFrame, but the lookup parts for user space binary is still enabled.
We have, nowadays we have acceleration for finding dwarf unbinding information, and this Claudio has also enhanced that to cover the SFrame program header as well. So that part is unconditionally available if you want to use that.
So the backtrace support in glibc does work well with the SFrame version 2 errata 1 release. So the minimum binutils requirement is 245, and it's supported for x86 64 and AR64. The backtrace function does fall back on the dwarf stack tracing APIs. If at any point during stack tracing you land at a frame where there is no SFrame for it, it does fall back onto the dwarf stack unwinder APIs. And fundamentally speaking, if all or most of the user space is compiled with SFrame, you will always be sticking into these APIs which are continually using SFrame information for stack tracing. There was a thing around marking outermost frame, which I will talk about towards the end of my slides. But as far as the user experience goes, you do see, of course, the interface is the same, so you see stack trace, but it's generated by using SFrame if the binary supports SFrame. Well, if the user space stack is built with SFrame. So internally, I think Claudio can also speak more later on this if there are questions, but internally in the DL find object data structure, we added a new member to keep track of where the SFrame data is, and if SFrame data is available for program, you will find that the appropriate flags are set. So this is again by and large internal, but this is one of the notes that in case there are some ABI checkers which are trying to check any incompatibilities between different glibc releases, maybe this becomes a thing. This may get flagged, so just sort of a heads up. On the kernel side then, so since we last met, there has been progress on the kernel side too. Steve is here, Steve, Josh, and well, there are more folks, Namyoung too, who have been doing most of the work on the kernel side. So on the kernel side, for user space stack tracing, so far there has been an FP-based stack tracer, right? Now, as soon as you shift from anything FP-based to something like SFrame, where SFrame data is actually in user space memory. So if the kernel is asked to stack trace user application, it cannot just go and read the SFrame section, which is in user space, because in certain kernel contexts, this can fault. You cannot be accessing user space memory, this may fault. So which means that the way the kernel has been, and this was not necessary earlier because everything was floating point based, floating point, Jesus, frame pointer based, FP. It's just the brain, the index is messed up, okay. Frame pointer based, right? So now you need it for SFrame because in the kernel you don't want to be faulting, and so what is done in the kernel is then infrastructure change. So when the kernel is asked for a stack trace for user space, it just registers that there is going to be a stack trace, it assigns that work some cookie, and on the return to user space, that work is served, and the stack trace is attached to the cookie, more or less. Okay.
It does a callback with the cookie as the identifier
for
It's fantastic. I've been wishing for this for ages. We had this problem with FP-based back traces with dtrace as well, and finally being able to get reliable stack traces with this is just going to be wonderful.
This is the baseline work, right? Once deferred stack traces are in place, then perf uptakes this interface and also gives you the capability of getting stack traces quickly rather than perf having to save off user space stacks for a later unwind using dwarf and so on, right? So this is sort of very fundamental. Once this piece is already in the kernel, by the way, right? There might be some iterations to fix some bugs here and there, and Steve had a great talk on this, so if you guys are interested, I think the video should follow. I don't think it was here earlier. But with that in place, the next piece that falls in line is the perf use of the deferred stack trace infrastructure. And finally, the piece that needs to fall in place is the SFrame stack tracer. So these three patch sets, by the way, have been evolving So far, this patch sets have been testing with what we released in binutils 244, which was version 2. SFrame itself has evolved to SFrame version 2 errata 1. So these patch sets, well, we just sort of keep testing as this format evolves. But so far, things look good. Things have been working. On the kernel space stack tracing side, there is a patch set. So what they're trying to do on the kernel space side of things is, so far for kernel space stack tracers, stack tracing, ORC was the format for x86. But for ARM64, there was no such thing. So on ARM64, it was just frame pointer.
Correct.
Kernel space. Yeah.
Just a frame pointer base.
So frame pointer has its reliability issues. How do you, I don't know. Okay, how do you how do you do live patching of kernel space if you do not have reliable stack traces? Maybe there were some, heuristics there, but you could still do live patching. So here the premise is that since you now have reliable stack traces using SFrame, can we do better? So yeah, they basically plan to, well, they've been testing with SFrame stack tracer, and the patch set is in progress. And so ORC cannot be used for ARM64 because ORC is very x86 specific right now. If you do have to take it to kernel space ARM64, it will need extensions anyway. And SFrame is basically a format that you can use on ARM64, x86, and now S392. So more or less, this is all I have to say around the stack spacer side of things. So So yeah, this is the stack tracer update for glibc and the Linux kernel side. Other news, LLVM support is coming along. I've seen some pull requests, but the linker side of pull requests I think still are to be seen. It seems to be going well. For the mold side, we did file up an issue, and when the support arrives, it'll be good to have SFrame support and all the major, linker implementations. Okay, so SFrame V3, we have been keeping a list of items that we want to support for SFrame V3. This is mostly a curated list of, I don't know, some user requests, some patch reviews. So the plan is still to go to target binutils 246 with it. I think it's doable. And this is how the support will look like by and large. So the assembler and the linker will by default generate V3 only. Object-dump readelf support will continue to support V2 sections. And the updated linker, so the new linker will not take a V2 section and automatically upgrade it to V3. And similarly, it will not link out an SFrame V2 section. And the thinking here is that if the user space, as and when the user space does pick up V3, does pick up SFrame, let's just pick V3 and start from there. When we do iterate, well, there will be iterations for sure. If the format sticks around, right, there might be iterations. And from there onwards, we do the right thing, as in we will do our necessary bit to support all the versions that are currently active in user space. But for now, I think the thing we are targeting is just support V3 and look forward from there. I am not going to talk about all the things that we are targeting for V3, but maybe 3 specific ones which I have not talked in the last call run, so that's all. So support for text greater than 2 GIB, explicit marker for outermost frame, and marking signal frames. So currently, if you give the GNU linker some set of input binaries, and the overall text, the final text that the linker generates, if it's greater than 2 GIB, right now you will see some errors. And this, by the way, this error is not just SFrame. You will also see the same error with EHFrame, because both SFrame and EHFrame are keeping an offset, which is 32 bits. So this should not be a problem, because there's no PR, no issue file for it. So most likely none of the user space applications are going into the, are going over, are having text greater than 2 GIB.
Just just FYI, talking with Meta, they said their applications are currently at, what, 1.5 gigs?
1.5 gigs, yeah.
And increasing. So this is something that's not far off from
Yeah.
becoming a problem.
Even in userspace, Chromium has now broken the 500 meg barrier, so eventually it's going to get there too.
Yeah.
It seems like it's a good thing to tackle now and not so that you don't have to worry about it for future. So this is what FDE looks like, right? So on left-hand side, we have this. So this is the information that FDE keeps, and the first entity that you see here, which is the function start PC offset. Basically, in each of this metadata for a function, SFrame keeps the distance from this field to the start PC of the function in text, and this is pretty standard in ELF, as in you'll keep offsets between sections, because as and when the binary is loaded to a different address, you are not required to do any load time relocations or startup time relocations, right? So this is pretty standard, but the problem here is obviously that it is a 32-bit offset. You do hit that 2 GIB limit. So the solution is to extend this to 64 bits, but you don't want to bloat the format so much. So if you were to just change this 32-bit to 64-bit, we saw that the section size changes by 6 to 7% increase. There is a 6 to 7% increase. So ideally, you would want to keep, so we just did that exercise, okay, can we do something better? We had added padding earlier just to keep these FDEs aligned. So it's one of the things in SFrame, like you try to keep as much accesses aligned as possible until the point it starts hurting your compaction. So, but we have been keeping SFrame header and SFrame FDEs aligned all the time, but now we can use these padding bits. For example, you cut off the padding bits and we realize that the number of FREs, you don't need to be 32 bits. You will still be sufficiently large if you were to change this field to 16 bits. So overall, there will be no change in the SFrame section sizes, and you can still go to support text greater than 2 GIB. We can skip the rest of the image for now. So this feature should make it to 246. The second feature that Jens is working on, he did talk about this briefly in his presentation too. Well, actually, he did give more detail, so I'll talk briefly about it. Marking outermost frames. So far, SFrame has not had capability to indicate the outermost frame. Dwarf does have this capability. Dwarf clearly indicates DWCFA undefined. And this is good for consumers because then a stack tracer can know that if your stack trace has it ended because this was the topmost frame, or is this because you had no SFrame section for it? So it helps, and the way we plan to encode it in SFrame section is to basically an FRE with no offsets. There is no format change necessary as such, but yeah, and I think we have communicated this to the LLVM guys too, so, but we should make a note in the specification anyway. Okay, so now I'm moving on to, so we talked about two of those items, right? We talked about support for text greater than 2 GIB, marking outermost frames. Oh, I don't have a slide for signal frame. Oof, okay. Okay, so now then I'm moving on to the item which was an ask by some of the folks as to remove unaligned accesses, to avoid unaligned accesses in FREs. So recall the initial diagram we showed, which was around what is an FRE. So basically FRE keeps these stack offsets, right? What is the offset for CFA? What is the offset for FP and RA? So fundamentally, there are two or three different kind of FREs that we keep in SFrame section, and this is more or less the layout. Each FRE starts with an offset. So if there is a function of 80 bytes, all you want to encode is how far deep down in this function you are. So maybe you are at offset 45 in this function. So basically, this FRE start address, all you have to, the size that you need for that is contingent on the size of the function. So you could choose an FRE where the start addresses do not need larger than 255 bytes and so on and so forth. But all the offsets are encoded as varlen data, like trailing bytes in each FRE. So I'm trying to drive to the point of where are the unaligned accesses coming from. Unaligned accesses are coming from basically accesses to these PC offsets. So this is an FRE. Okay, going back. Each FDE had an offset, and this is one FRE. You indicate what is the start PC of a particular blob of stack trace data, some information on how to access the Varlan stream, which basically contains those stack offsets, right? And for each function, you have a continuous, you have a series of these FREs in a contiguous block of data. So summary, yeah, there are unaligned accesses. They are coming from basically these PC offset from this field here, and the Varlan data, basically the stack offsets. So the ask was that these unaligned accesses, if the stack tracer is, a stack tracer in the wild may incur some performance penalty, because if these accesses are two unaligned accesses, some hardwares have, hardware may show performance penalty. But over time, we have seen that newer hardware do not have, I mean, it's not a pathological case for newer hardware. So maybe I skipped this, but summary being, we did explore a few different layouts for FREs. There is a discussion on the upstream bin utils mailing list if you're curious. But you could change, like you could put all 8-bit, you could do some hacks around, okay, let's put 8-bit stuff together, then 16, and maybe introduce some padding. All said and done, yeah, there are strategies, but we noticed that, for example, any sort of rearrangement or even adding some indexes here and there will bloat up your format by 20 to 30%. And so it's not worth it. Bottom line being, it is not going to be worth it. And I think there is consensus across the board that the central challenge here is that...
So it's a question not for you, but for Florian. What is the policy in glibc about mem copies? Because probably we need to use mem copies to align.
So if the target in the GCC target is reasonably maintained, then what GCC will do, it will inline the mem copy and use, usually it's on the fast unaligned access targets, is just 4-byte load or something like that. The other thing you can do, you can write out the bit manipulation, and then GCC will also combine that in the other direction, like for the unaligned, fast unaligned architectures, you get a single memory load as well. So yeah, it is a matter of taste what you think is preferable. If you should check if there are any mem copy calls in the generated code, and there shouldn't be any. That won't land with glibc anyway.
Insofar as there's a performance hit, we're going to be getting a performance hit from accessing memory at all. Yeah? Insofar as there's a performance hit, accessing memory is going to be 100-fold slower than accessing anything else, whether it's aligned or not. So that's where your performance hit's going to come from, regardless.
Still, we need to...
So the mem copy is not going to have any performance implications. Okay.
I'm aware that there's also the possibility of using variable length ints, at least in bin utils. Is that something that has been taken into account, rather than have fixed length? 32, rather than going 32 or 64, like having it more variable.
So that's not always possible, right? For some of the fields, there are offsets encoded where you don't know the final value before linking. So you can't use variable length encoding for all these fields, because only the linker will know, and then the stuff needs to fit whatever you had there, right? And so yeah, right. So for some, of course, it could be used variable length encodings, ULIP 128 or something, but I don't think it really makes much sense. Your sections will get, I don't know, 10% smaller, and your decoding time will grow up. But yes, there was discussion.
Even more than that, most of these
Most of these things are distances from start of. And if you think about it, for example, the distance from the start of .text, the only situation in which shrinking to 16 bits would be helpful would be for programs that are so small that that sort of space improvement would mean nothing. But for things that need 64-bit offsets from .text, the programs for which that matters are so gigantic that a few percent of an increase to the FREs is just, or the FDE is just irrelevant. All that really matters is that the common case is reasonable, and 32 bits seems like a reasonable common case.
Yeah, at least for the data that makes it, for user interfacing, like inside the section, so we consciously made the choice to not take up LEB style encoding because it gets more tricky to decode at the time of stack tracing. But yeah, on the, relocation stuff, yeah, there's little choice there. Like I don't think you can use the LEB style encoding there. Yeah, so the consensus at the moment is we continue to have unaligned accesses. We want to keep the data compact, and this is a good trade-off. Let's stick with it now. And if there are architectures or platforms that show up which do not allow unaligned accesses, we do use memcopy. And by the way, in libSFrame we do it because the sanitizer, or if you do some runs, then it was flagging. So we do use memcopy in libSFrame. So that brings me to all the updates that I had to share about SFrame section. Now I added this section because it's been an ongoing discussion and I do need some inputs and maybe get some ideas here too. So now it's a BOF style. The session is switching to a BOF style, format. So if you guys have anything that you want to bring up after this, then we can talk about it. So many of the decisions were also driven by how frame sits, as an ELF citizen. But now that we are progressing into more of distro-wide testing, there is one issue that showed up. Now, on the face of it, the issue is nascent, or what's the word? The issue is innocent, sorry. The issue is innocent, as in, so this is an issue where you're building LLVM with an assembler which generates SFrame sections, but LLVM is then using an LLD, right? The LLD linker is being used to link these objects. LLD at the moment is an SFrame unaware linker, right? So fundamentally the problem is this. So if the linker sees two text sections for providing a definition of a symbol, the linker sees I need to pick one definition, it picks it. Now in this particular issue there are SFrame sections corresponding to the text, the objects. Now, if you remove one text, what should an unaware linker do with these SFrame sections? So at the moment, it is correct for an unaware linker to simply concatenate these. But recall that SFrame sections hold a relocation to point to what is the start PC of the function, which means that if you have concatenated these SFrame sections, there is a hanging relocation which shouldn't have existed. Further, this whole SFrame section shouldn't have been brought in. So again, as I said, so it looks innocent in the sense, well, it is good that LLD shows an error to the user that I don't know what to do with this section and it errors out. So the right thing to do there is, yes, add support to LLD. But it did bring up, the discussion did bring up a larger question that, is it possible to do better? Is it possible that we can have some way of SFrame sitting in these ELF binaries so that even an unaware linker, if it discards text, maybe also discard the corresponding SFrame section. Now to do that, the ELF provision is use SHF link order, right? So then the question becomes, okay, can SFrame use SHF link order? So recall then going back, SFrame is one section. It's a monolithic section. And the question then becomes, can you link SFrame sections with the corresponding text? Sure, you can do that, right? And I come back to the whole thing that, but SFrame section data itself still needs to be merged, right? That remains. But okay, so let's ignore for now that maybe concatenating SFrame section not generating correct output is not a problem. If we ignore that for now, I think the thing that's coming out here is that at least I think that SHF link order will not quite work. Okay, I think, wait, let me see if I'm confusing you. Okay, so let's think of the case then that there is only a single text section, right? If there's a single text section, you can have SFrame point to the corresponding text with SHF link order. Now, in case of SHT groups, so if you use F function sections in the compiler, it'll generate section group. If there is a section group with one text, you can still have SFrame point to that section group. Maybe things will work. But then what do you do if the SHT group has multiple texts? So things are starting to get hairy, I think, here. So yeah, I'm not sure if this will work. If
maybe with the group, right? So the underlying mechanism in ELF is a group consisting of one text or multiple text sections, doesn't matter, but a group is discarded as a whole or not discarded as a whole. So if, with the example of function sections, so you have multiple text sections, one per function, and then you would have to have as well multiple SFrame sections, each of them corresponding to the text parts that are in that group. Those will then be discarded together or not discarded together. They will only refer to members of that group, of which they themselves are members of. And well, that will all work, but of course, the concatenating is the problem, right?
Yep.
You can, when you just concatenate blindly multiple SFrame sections, you won't, the end result will not be a properly formatted SFrame section.
right.
I don't think it has anything to do what to do with discarded sections or not, because that is solved by groups.
Mm-hmm. So you can.
But the concatenating thingy is the showbreaker basically. So for linkers that can't properly merge SFrame sections, yeah, well, they can't emit SFrame sections. Then that's the gist of it.
So you can have a group of sections linked to another group of sections. That should just work fine?
Yes.
Okay.
Yes. So if there is a reason for the linker to think that the one group is required, then the relocations, I mean, pointing to something else is a relocation, right? So these relocations will make the other groups be necessary as well.
But it sounds like you don't need that. A group can literally contain the text section and the SFrame references that text section.
Yeah, right.
Together.
No. So in this case, I remember, so in this case, the interface between the compiler and the assembler is this CFI. The compiler doesn't emit the group with SFrame section. The compiler emits a group with text and whatever debug the compiler could generate here. The case of F function sections, right? It's the assembler that comes into picture and it says, oh, I have a group with sections. So it generates a group with SFrame sections. So then if we were to go this route, what we are saying is there's a group with SFrame sections being linked to a group.
No. Oh, no, sorry. No, that wasn't.
No, but that's what we'll need here, right?
No. What we need here is, if you have a snippet text section, text.foobar for the foobar function, you also need an sframe.foobar section, and both of these are members of the group foobar.
No, but that cannot be done because assembler will not edit a group. Suppose you use F function.
Yes, but it has to. That's the thing that the assembler needs to emit for the whole scheme to work.
It is technically possible for the assembler to add extra sections into a group.
Yeah.
It can be done.
Okay, I thought that would be hacky.
No, it is the proper representation of entities belonging together.
Even if the compiler was the first entity to have generated a group, assembler can add things to an existing group?
Yeah, it's basically, as far as the GNU toolchain is concerned, it's just text files, right? And if the CFE directives, if they generate their blobs into the SFrame section or into the SFrame or into the group foobar variant of the SFrame section, that doesn't really matter at the end.
Okay, then it's just simpler. I was complicating it.
Sorry. And the other thing I wanted to point out was that the SFrame section, you only need as the output from the linker. the inputs could be multiple sub SFrame sections. So you could have one that's just the header, one that's the FRE, one's the whole FDEs. And it's perfectly safe to concatenate the FDEs, right? You just need to get the right offsets in the FRE to the FDEs, now FDEs to FREs, and the header to the FRE. And so you can do all of that via relocations at link time.
Yes and no. So FREs can be concatenated, no trouble with that. FDEs is sort of an index. Okay, so that's where you need the SHF link order. So if the assembler is generating 3 of these sections, say header, index, and FREs, you do need the FREs to be emitted as an index. So they should be in the same order as text.
Right.
So that, yes, so intersection you can still do with relocations, correct?
Can you bring up the graph with the format of the? Was it that one?
No, it was.
This one?
No, I think I want to have the detailed format of
Yeah,
the
that's another
FDS.
one.
Okay.
No.
No?
No, wait. And that's the left side is FDEs, right side is FREs. Yes, this.
Yeah.
Okay. So why do the FDEs need to be in any particular order? They refer, as far as I see, to the function by a number that basically represents the function by the program counter, and then it's self-contained.
Yeah, but it is an index. For a stack tracer, it would want to find out using binary search. So we keep it as an index in the same order as text, as functions in text appear.
The kernel will actually search the FDE.
Yeah.
Sure, but that just means that the FDEs need to be in increasing start PC
Yes? Yes.
order, right?
So there is an order obligation there, yeah.
Okay, yes, is that a problem?
The order obligation is not really a problem. I think if you use the SHF link order, things flow. But it's the problem of how do you indicate to a reader that this index contains n number of elements. The linker can do the right thing by, putting these entries in particular order, but take this to executable or shared object, which only sees blobs of data. It doesn't really see size of sections. Then you still need to indicate the size of this index.
Yeah, sure.
Yeah.
That's the next problem.
Okay.
First, are we talking about problems having to do with?
So what problem do we want to solve? The problem is, do we want to do? It's a thought experiment. Like, can we do better being an elf citizen? Okay, maybe I don't flip and just talk. The fundamental thing is, the question is, can we do better? SFrame specification. Can SFrame specification do something so it is more linker friendly? But I think that's a different way of saying linker friendly. It's subjective. Linker friendly or elf citizen. What kind of an elf citizen is it? How harder a life should it be for an unaware linker?
Clean things up automatically when GC sections are used, that sort of thing. Yeah.
So in Fedora, we have at least 8 or so linkers.
Sorry, 8?
Yeah, there's one in Golang. I think there's one in FPC, the Pascal compiler. Then LD, Gold, BFD LD.
Mold, and there's Wild, which is
Yeah, Mold, Wild.
maybe more than 8.
Yeah, and the kernel has to read the objects as well, so that's another one. GHC needs to.
I want to say that it would be really, really nice to.
Yeah, I mean, the best possible outcome we can hope for is that we can still link it and it just produces data that is ignored.
Yeah.
And that shouldn't be too hard to achieve because you need the GNU SFrame program
type.
header, and a linker that doesn't support it will just not generate it. So it's just dormant allocated data.
Yeah, you can. So If the linker doesn't care about SFrame sections, it can now just check for the section type and error out. So it shouldn't be too difficult for...
Error out is a problem for us, because the distribution has SFrame data and our linkers can't cope with it. I mean, if the problem is if I roll this out today in Fedora, then anything LLM based won't work, right?
Won't work, yeah.
Yeah, and that is a bit of a non-starter for us at this point.
But if it is easy for a consumer to determine, oh, sorry. I mean, will it be such a problem to have like binaries with invalid SFrame sections like concatenated if it is easy for a consumer to actually determine when the SFrame is valid or not? Yes. Because if you have sections with SFrame concatenated, well, so what? I mean, my point is the linker that doesn't know anything about it can do the wrong thing, and it is on the consumer side, right? So given an SFrame section, you can easily determine what is the end of the SFrame section data, right? Mm-hmm. Not of the ELF section. So you can just jump there and see if there is a magic number, right? If there is another header, and if there is, you know that that's not valid SFrame. This makes sense? I mean, distro-wise, like system-wise. It's not very hygienic, but...
We have a similar issue with the GNU property nodes that we introduced to mark binaries for shadow stack and indirect branch stacking support on x86. And I don't know what we did there. That is so far back that I don't remember anymore. But maybe there's something to be gleaned from that as well.
I have to wonder why concatenated SFrame sections is invalid. I mean, you can work out from the first one where the end ought to be, and you can jump there and see if you've reached the end of the SFrame section. If not, you've got another one that's been concatenated, and just keep on walking down it, parsing as you go. Why does it matter?
It's index, because we need an index. Index is inbuilt into the format, so...
Right, but you can compensate for the offset of the indexes, can't you?
You're not expecting a second index.
I mean, the stack tracers will have a harder life there, right?
Yes.
You parse differently and...
So what Steve said.
Yeah. Basically, that is it.
Okay, but I mean, all right, then.
Sorry, I missed that.
Would you be okay with 2 indexes?
Or multiple, one of
Because that sounds like a pain. Wait.
No. So in that case, what you will see, if you are linking, say, 10 objects, you'll see 10 SFrame sections. Mm-hmm. So potentially it could be n number of indexes.
No, we will be having that regardless, because every time we link in a new file, we're going to get a separate SFrame section. So we plan on if you, for dynamic linking, okay, I'm sorry, Ms. I was actually catching up on some work.
No.
So basically, if you have like 5 libraries, the dynamic linker loads in. It's going to have 5 different SFrame sections that are going to be registered for that program. And every time we have that system call, the system call will be done for every single one. Then we're going to have a linked list of actually a sorted array, or actually probably not a linked list, but actually an array of SFrame sections. And that's going to have an index of what text sections this will arrange. So we're going to use the array first to do a binary search on the first array, then we're going to do the binary search of the indexes of the SFrame.
But in this case, it is like you're talking about the abstraction of binary and shared libraries.
Yes.
I think what is being driven here is, why is it a problem for stack tracer to then go see for a specific artifact, which is either executable or shared library. Inside this, you can also have further number of indexes. So this is second level. We don't want that. We only want one index for one mapped file.
But you're computing your
I know why. Okay. I can say why it won't work. Because if you just concatenate stuff, so if the SFrame section individually consists of multiple pieces of SFrame fragments, each of them will have a sorted list of FDEs, but if you sort all of them together, they might you know, the second segment might be intermingled if you would sort them with the first segment. So you can't do binary search in the individual pieces anymore and get the correct result.
Well, if you apply an offset, yes. I think I think I see what you mean. Like if you have the different SFrame sections concatenated, the same order that the corresponding text sections were concatenated.
Oh, I see.
Then you can linear search in the different SFrame sections, and then binary search applying what an offset.
I mean, yes, so in theory it will work.
This?
In theory it will work, but it makes the life of stack tracer not, it is not an ideal life of a stack tracer to be in. You do want to do binary search. The first thing you want to do is binary search, not linear and then binary. It's not
We don't
worth-
want to do any linear search. Remember, we have to do this for every instance of the stack. So if you have
Yeah.
a 50 instances, we got to do this 50 times.
Yeah.
So we don't want a linear search. That means there'll be a linear search 50 times.
But this solution works with the linkers as they exist today and all of them.
Yeah, but we have to make Steve happy.
Imagine
Because it doesn't work to the free. There's no point.
Oh, yes.
How many SFrame sections would you have concatenated if you use function sections? Thousands. Like millions?
1 million.
Yeah. Yeah.
So linear search that.
Yeah.
That's a problem.
You can always reduce the linear search for binary search by coming up with an offset table and then sorting that. But you really don't want to do that in the middle of it.
The S of SFrame is more simple, but simple for the user. It's radical concept.
You can do the sorting. You can do the sorting at registration time.
What's that?
You can do the sorting at registration time, but none of this solves the problem that we don't generate the GNU SFrame program header that you need to find that data. That definitely needs linker support.
Yes. And it won't be trivial there because you do need to read these sections then and create a index. It may not be the right abstraction to do it at that time. So
earlier I had the idea that the old hack with init sections where you have basically a marker at CRT begin and another marker at CRT end. And then you can surround the SFrame sections by something and you don't need to have linker support for creating the dynamic text. Obviously that it's meh, right? So, or you can use the start of and end of section symbols, but that only works with the GNU linker. So it's all, so without linker support, it's going to be difficult anyway. And then we can just as well also do special merging, or require special merging support from linkers.
Yes.
I think without that.
There's a flag you can set OS non-conforming, I think, that says this needs special handling, and if you don't know how to handle it, abort.
But it's not that we have like 500,000 linkers, right?
No, but we do.
It's like how many? 8?
No, but trying to get something into just one is not going to be, like for mold, we haven't had a response yet. I mean, that's fine, but it will take time. It will take a lot of time. And the context for this is that the LLD maintainer was sort of looking at SFrames and sort of decided that it looked too much like FFrame. And essentially that they didn't want FFrame 2.0 and that they didn't really want to add support into LLD. And there was a sort of implied we'll block it if there aren't changes. So we need to do something to accommodate them. And even if there wasn't this issue, Florian is right anyway, there will always be these like strange linkers that we can't really control. Like, have you tried upstreaming something to Go?
Well, if they want one of the motivations is they want, quality profiling, maybe that would be enough for them to be motivated.
That's true, actually, that is true. But
yeah.
FPC, it's...
Yeah, but then I still don't get this thing about doing something sensible by concatenating. Like, again, okay, you concatenate SFrames, but if that is done for every unknown section type name and flags combination, does it mean that everything that we will ever put in an elf section is supposed to be concatenated concatenated, then it still makes sense.
Yes, SFG proc bits, basically the.
No, but it's not. That's
So-
the thing. It's not proc bits, it's unknown.
Yeah, that's why I argued for having a special section type.
Yeah, right.
Yep.
Okay, but this is considering that we adopt the special section.
I think that's already in.
Section type is already there. We already have the GNU
Yeah, yeah.
size.
So
Okay, so then why is ELF sort of expects for the concatenation?
no, it's not. It's not.
No, no, ELF standard.
If you don't recognize the section type, concatenate.
Yeah.
Okay, so maybe we should we should just as a community decide if you don't know the section type, then maybe don't do any error out or ignore the sections. Or
Yeah, but if the LLD maintainer is using the ELF specification, maybe he's reading too much into it, in the sense that, yeah, if it is unknown, just concatenate.
But it actually says that in the standard.
yeah, it says
It's clear.
that's correct.
Yes, but in this case, is it unknown?
Yeah.
It's unknown to the ELF standard. The ELF
To the-
standard doesn't have S-frame section type in it.
But this is a bug in the ELF specification, because then, I mean, it wasn't the proc bits that are supposed to make sense when you concatenate.
It's a
strange
It's a bug
system,
in
I don't
there.
know
Yes.
why.
It's a bug.
But isn't the problem that you're mentioning here one of performance? I mean, if you have something like Chrome and they use a linker that is not suited for Chrome and it concatenates a million entries, the reader will read it. It's going to be dog slow, but it's the problem of whoever used that linker.
No, the linker, the user will not make sense of it because no one will implement a strange sorting necessary.
Getting back to this rejected idea of just concatenate them, you could always then have a post-link tool that processes the SFrame data and generates a sync. Why not? It would solve the problem, wouldn't it?
What happened to the Dorf one?
Yeah.
Right.
Well, we still have that, but
Yeah, go ahead. I don't get distracted with my flipping.
Is now maintained again, right? Carrie is taking care.
yeah.
So let's fix this.
No,
I mean, not this.
let's not get into
solution.
ELF
discussions. It will never get fixed.
Okay, yeah, basically, I just wanted to see, I've been talking to Fangry, by the way, Fangry and Alexander too, on and off, but we have been communicating a bit, but yeah, in general,
It's a philosophical.
yes. And it's not just SFrame. I think in hindsight, if you look back, each frame has a similar need to indicate something which is an index. Debug names is another section where you do need this index. This is not a first-class citizen in LD yet. GNU LD doesn't support debug names, but if at all this comes, similar problems will be seen to a lesser extent maybe, but still, because their indexes are simpler, SFrame tries to really go on, over the board with it and says, okay, I have better ideas for compaction, let me do everything together. Again, nothing wrong with it, right? It's just how we specified the format. We knew it'll work well for stack tracers. And okay, so it was sort of a third experiment that I wanted to bring it up. Thank you for some ideas here. Nick did mention earlier that one of the options could be, okay, let's split it up, but I still continue to see issues with it, like there is no provision right now that supports this right away. You do need, for example, to indicate that this is an index section, I do need to carry header, basically. So even if I split this data into 3 different sections, there is a header, SFrame IDX, and SFrame info. You generate these in the same section group, fine. And then suppose you figure out a way to then, in the link binary, you just create one SFrame header. I don't know how, but fundamentally, you do need the header. You cannot get rid of it, because in that, I keep some bits and pieces around how is the format evolving, what are the version and flags, and most importantly, the number of FDE entries I needed to be there so that the index is usable for stack tracers, right? So I think that is it. If we can just, maybe I'll continue discussing with some of you, but if there are any further topics for SFrame.
Anything we need to know about the system call?
System call, yeah. So Matthew had sent earlier an RFC, and he proposed that we could do something. So moving away from PRCTL, add a system call. The interface that was earlier being proposed was also including some build ID or ELF markers, which we over time decided we don't need. So the minimal necessary interface there is start and end of the mapped binary with the start and end for SFrame. This should work well, as we know of, for the shared libraries. When they do DL open and close, this should be enough for registering. So I don't know if
And,
you...
yeah, so basically you have an ID of what type, because we might have things like for JITs and things else, a different format. So one will have like a defined thing, a type, I'm saying this is an SFrame section. Then we have the start end of the text section the SFrame section represents, and the SFrame section itself. Is that enough for, like, for if you're loading for each file that you dynamically load for every library? Just having a single, here's the text range, here's the SFrame section range. I'm assuming that a dynamic library, well, you'll never get two dynamic libraries that are interleaved, where their text is interleaved somehow. That's...
So if the kernel maps things, then they can have gaps, and you can mmap stuff into the gap. Because on AR64 for example, the binary is layout for 64K pages usually, and if the system has 4K pages, then you get holes between the mappings where there's nothing mapped, and that can be large enough to place something else there. But that isn't really a problem for that, because when we do the registration on the glibc side, we know the text segment boundaries based on the load segment flags. And if there's some discontinuity there, then we just do multiple registrations.
Okay, so basically, yeah, so if you were to split it up, so if a library had, library A, B, A, B, it was somehow mapped like that, you'd have to do a system call for A, a system call for B, a system call for A.
Yeah, I think we wouldn't even notice, because we just loop over the load segments and only register the load segments. The question is, if we want to cover data load segments as well, then it gets a bit more complicated. Because, but my understanding is for this, you don't want coverage for data segments at all.
We only care about text segments. So it's only text and the SFrame that represent that text. It's okay if the same SFrame represented two different, so if you would do, so say if you have one SFrame that represents two texts that are separated with a gap, and even there's a third one in the middle, you'd have to register that this text goes with this SFrame, this text goes with the same SFrame. And then for another library, you would say this, as long as each text is registered separately. Because that's how
but you need to be careful about, maybe we need an extra offset there for the second registration, because the offset is not going to be 0 according to...
So have an offset? So we got, so...
it depends on what the format says in terms of how, if it's a virtual offset or...
So for all the text that the linker sees, it will emit one SFrame section for it, which means that for if in a shared library you see a PT load segment with text in it, you will also see the SFrame section alongside. So I think you're talking more on the sense that so the text sections may be laid out as in how the linker may want to lay them out. That is immaterial here, right? On the segment side, you just need to be aware of the PT load segment and the PT GNU SFrame ELF header when it points to the specific SFrame.
Are the text offsets in the SFrame segment relative to the start of the load segment, or relative to the start of the shared object?
I don't understand that question.
Are they virtual addresses or relative to the start to the load segment?
They are relative to the start of the load segment.
Okay, then we need the offset.
What's that?
We need the offset for the second registration.
So imagine you have two text segments.
Yeah.
and one SFrame segment. Then, so 2 text segments, 1 SFrame segment. There will be entries that are relative to the first segment, and there will be entries that are relative to the second segment. So you may have, for instance, 2 entries with offset 0, one referring to the one and the other referring to the other. But actually, how would you differ between the 2 entries in a reader anyway?
You can use the offset from the lower load segment.
Yeah, you have to, and then you don't need an offset for the registration anymore.
Yeah, so my understanding is that, my understanding is when the S-frame is created, or after it's final linked, or whatever it's linked there, you have the S-frame, the S-frame expects the two text segments to be at a specific offset from itself, correct? So, I mean, you can't just randomly, you have 2 loads, you're not going to randomly put them separate. There's going to be, the 2 loads are going to be fixed between themselves. The offset between the 2 loads will always be fixed, and it's going to be fixed between the S-frame section itself. This is why we don't really need an offset for this, because the S-frame the offset is in the S-frame section that will say, I know how to get to the first one, I know how to get to the second one. You can put it anywhere in virtual address, but
Okay, so it's a virtual address offset.
right, no, yeah, basically you just tell me where, yeah. No, you just tell, like when we tell me, it's because here's where the load, like this, you give me the virtual address of this is where the text section is, this is where the this is where the S-frame is. And then the S-frame will know the offset, because the S-frame uses offsets, it doesn't use the direct address.
Yes.
Virtual offset from the physical address.
Right.
From the load address. So, sorry.
That's can't work.
So the offset is from the function descriptor entry to the function.
And according to, based on virtual address.
Yes.
Okay, that should work.
So we don't need the offset then?
I think so.
Okay. So right now I think it's just identifier and text and S-frame that we're going to have right now.
Identifier, text, and S-frame?
Well, identifier, and okay, so the identifier, the text start end,
Yeah.
S-frame start end,
Yeah.
start size,
Yeah.
So it'll be 5 parameters. And we might add flags for something, I don't know. just for extensibility.
Yeah.
Yeah.
I thought it was also, according to the flag, you can also pass a void or some other, argument to it, depending on if you want to pass more information for JIT, you want to piggyback on another argument.
Well, the thing is, then we could do, like I said, the first one's going to be the type, which will be S-frame. And if you make a JIT type, it could say, okay, JIT type will have 4 parameters.
Okay.
We could have, because system calls can't have more than a fixed number of parameters if we need it. But we might still just say, have maybe name, flags, text start, and sex, and well, how many is that? It's already got 6 parameters, right?
6.
And usually system calls don't have, is there a max?
It starts at 7, where the problems start at 7.
Right, so I don't think we're, so basically, so we might just have it with that, because one of my ideas is when we do, like if we say JIT and we need more information, the memory, because we're going to be reading, it's like we're going to be pointing to like the S-frame. Actually, it might be S-frame first, then text, or maybe, text and then S-frame. But like the S-frame has information on how to do more. For JIT information, we're planning on having the memory be the API, so we could have some special memory that says, here's the size and length. So all the size and information could actually be in the memory itself that you're pointing to.
So it's basically a descriptor then?
Yes. Yeah, so basically the first type. So we might not even need flags. So we could drop the flag. So it might just be identifier, this, and that.
I mean, it could be interesting to attach metadata to any type of mapping.
Yes. Yeah, exactly. In fact, actually, that's what I was thinking, because especially in JIT, they don't want to make a system call for every time they do load this. So it's just all the information, the updates will be done. You're going to tell the kernel, here's where the information is for this stack, for this text. I'm going to extend it. eventually extend it as well, so you don't have to do system calls. You can actually just change some memory, and the kernel, when the kernel does its stack walk, it will see that this do update and say, okay, this has been updated, do something different.
Any other SFrame related things? I think time's up, but okay, thank you.